Hello, everyone. We will be looking at alcohols and phenols. So, what are alcohols? Alcohols are, in fact, organic compounds that contain the hydroxyl group, OH. It has formulas near or close to alkane, and the alkane formula is CnH2n plus 2. And sorry, I have CnHCN plus 2. So, it's um the The alcohol would be CnH2n plus 1 OH. And um, so moving on now to phenols. Phenols. Okay, so we're still on alcohol nomenclature. We'll be looking at some alcohols, their examples. We'll be looking at how you name the alcohols or IUPAC name. So let's just do that now. Number one, find the longest carbon chain containing the OH. If there is a chain with more carbons than one carbon containing the OH group, it will be named as a substituent. And drop the E from the alkane to add OL. Number the chain starting from the end closest to the OH group. Use a number to indicate possession of OH group. So some examples of some alcohols are first, when you're naming them, you're gonna add the prefix. So you have ethanol, methanol corresponding to 1, ethanol for 2, propanol for 3, butanol for pentanol 5, and it goes down the list right to 16. So cyclic alcohols have cycle before the parent name. Numbering begins at the OH group going in direction that gives substituents lowest possible numbers. So here are some examples. 2-butanol, as 2-butanol is a secondary alcohol, as the OH is on a second carbon. It's a 2-methyl 1-propanol is a primary alcohol, as OH is on the first carbon. And 2-methyl 2-propanol is a secondary alcohol, it's on a second carbon. And 3-bromo-3-methyl cyclohexanol is a tertiary alcohol. Those are some examples that I'll give the solution to soon. Alcohols can be classified as primary, secondary, or tertiary. Classification is based on the number of alkyl groups attached to the carbon to which the OH group is bonded. So we have primary alcohol examples here at where carbon which carries the OH group is only attached to one alkyl group. Methanol is counted as primary alcohol because even though there are no alkyl groups attached to the carbon with the OH group, on it, so it's on the first carbon. Carbon with the OH group attaches directly to two alkyl groups, which may be the same. So that's secondary alcohol. And tertiary is carbon atom holding the OH group is attached directly to 3 alkyl groups. And here are the examples. Phenols, compounds that have the OH attached to the carbon atom of an aromatic ring. Phenol, commonly named benzene as well. OH is assumed to be on carbon 1. So we looked at the structure of phenol here, and we are going to look at ortho, meta, and para. Ortho are substituents on the 1 and 2 position, meta are substituents on 1 and 3, and para on 1 and 4 position. So now there are 2 or more additional substituents. Each must be numbered, beginning at the OH and going in direction that gives substituents lowest numbers or alphabetical if same in both directions. So the first name is a common name and the second is the IUPAC name. So here are some examples. We have phenol, which OH group on the carbon 1. Now we have parachlorophenol, where chloro group is on fourth position and the OH on 1. Then we have metanitrophenol. Meta signify 1, 3 position. So the nitro on the third position, OH on the first position. And the 3,5-dinitrophenol, 2 nitro groups on the 3 and 5th, 3rd and 5th position. Sorry, it's also called 3,5-dinitrobenzenol. Hydrogen bonding. We call hydrogen bonding. Alcohols exhibit these bonds. Alkanes, the only intermolecular force are London dispersion forces. And hydrogen bonds are much stronger than London dispersion forces. Therefore, it takes more energy to separate alcohol molecules than it does to separate alkane molecules. The solubility of alcohol in water is the next topic here. The smaller alcohols are completely soluble in water. Only the first 3 alcohols are soluble in water. Solubility decreases as the hydrocarbon chain in the alcohol increase. Now we look at the hydrophilic and hydrophobic region. Hydrophilic region is the OH region, H slightly positive, or oxygen slightly negative. Hydrophobic region is the carbon and hydrogen region. It says as the hydrocarbon chain, which is a hydrophobic region, as it get longer, interfere with the ability of the OH group to hydrogen bond with water. Consider ethanol in pure water. The main intermolecular attractions are hydrogen bonding. Boiling point of alcohol and phenol. Alcohol and phenols have high relative boiling point. Phenol tend to have higher boiling point than alcohols of similar molecular weight because they have stronger intermolecular hydrogen bonding. This is because phenols have a stronger dipole difference in its OH group. The OH bond in phenol is more polar than in alcohol because the benzene ring has an electron withdrawing effect which further polarizes the OH bond. The greater polarity of this bond results in stronger hydrogen bonding and therefore higher boiling point, melting point, and water solubility of phenols when compared to alcohol. The boiling point of an alcohol is always much higher than that of the alkane with the same number of carbon atoms. The boiling point of the alcohols increase as the number of carbon atoms increase. Some are as acidic. So alcohols can be as acidic as water, whereas others are much less acidic. Substitution by electron withdrawing groups, halogens, enhance the acidity of alcohol because they help to stabilize alkoxide ion. Acidity of phenols. They're more acidic than alcohol. Phenols are more acidic because the anion that forms upon loss of the proton is stabilized by resonance. And because of their high acidity, phenols are often called carbolic acid. Here's an example of a resonance structure. We have H hydrogen coming off first of the structure, and we have BH forming. Lone pair comes onto the oxygen, and we see where curved arrows show the movement of electron, 6 electrons on the oxygen, and the negative, usually anion, moves around the ring structure, and the double bond breaks off, forming a double bond in the ring structure breaks off, forming a double bond on the oxygen. And so we have 2 double bonds moving in resonance form around the ring structure. Substituents affect the acidity. Electron withdrawing groups acidity increase acidity, and electron donating groups decrease acidity. So we have oxidation, addition of oxygen, loss of hydrogen, reduction, addition of hydrogen, loss of oxygen. So it's important for you to know these. Thank you for listening.